And now we get to continue on with our discussion about IP networking and discuss IP address classes. IP address classes is how people, when they created the internet, how they defined for things to be able to communicate with each other. And this is where I get to say my favorite phrase. My favorite phrase at all for computers is, computers are stupid. Believe it or not, computers are so stupid, in fact, that when we came up with IP networking, we had to end up jumping through a whole bunch of hoops for them to communicate with each other. So a little bit more information about IP address classes. So classes in IP addressing are used to help determine if a source and target system are on the same network or not. It's a way to be able to determine, should this stay within my network in my company, or should it go out onto the internet and go to somebody else's company? There are 5 classes defined, and there's a really great Wikipedia link here that shows all the information you will ever need about IP addressing. So specifically, when we look at this nice little map right here that they have, this shows what the internet looked like when it was first created and when these classical networks were put in. And in fact, when these classical networks were put in, it was very, very simple and it worked perfectly. So let's talk about it. Let's check out some information about it. So we have our 5 classes, A, B, C, D, and E. Class number A has a leading bit of 0. Now this may sound a little weird, but this is going back to my prior statement of computers are really stupid. This is how we start figuring out if something is a Class A network or a Class B network or something else. And it has to do with the leading bit. So we've previously talked about converting binary numbers, converting numbers to and from binary, and we learned that there are essentially 8 bits, and it's a mixture of 1s and 0s. Now, if you do the math for everything starting from 0 through 127, all of those numbers are going to start off with the very first binary bit of 0. So 0 is going to be 0, 0, 0, 0, 0, 0, 0, 0, and 127 is going to be 0, 1, 1, 1, 1, 1, 1, 1. So everything from 0 through 127 starts off with a 0. And that's how unintelligent, how not very smart these computers and routers were at the very beginning. They only looked at that very first bit to determine, is this a Class A network address? And if so, then I can treat it appropriately. So that's what it did. It looked at its very first bit just to determine its class type. So leading bits of only a 0. The network address size is 8 bits. Now, if we think of an address, let's say 12.47.16.212. This is a standard IP address format. I don't actually know what that goes to, so don't count me for it. And what it is we have 8 bits right here, 8 bits here, 8 bits here, and 8 bits here. So by having a network address size of 8 bits, we are saying this first chunk right here defines what our addresses are. And total, I have 128 total networks. If we go back to Wikipedia and we can look at, right here is a list of assigned /8 IPv4 address blocks, or essentially Class A address blocks. Well, we can start seeing that they in fact went ahead and assigned some address blocks. So everything that starts with a 4 is owned by Level 3 Communications. Everything that starts with a 17 is owned by Apple, and so on and so forth. And so that's the way the internet worked at the very beginning. If an address was created that was specifically, going too far there. If I wrote an address to something that started with a 56, then that means as I'm browsing out onto the internet, that 56 means it should go to the U.S. Post Office. Doesn't matter anything else. I saw a 56 and the internet would route me directly to the U.S. Post Office. So that's all the internet had to do. Just look at that first number. It was great. It was very simple. It was very elegant, and everything that was 56 went there. Everything that was 17 went to Apple. Everything that was 19 went to Ford, and so on and so forth. So it was a great and simple and elegant way in order to design the internet. The only problem with this method is the fact that because we only have 0 through 127, we have 128 networks total. Which means when these addresses were signed out or defined, we had large organizations, such as countries. We then had medium organizations and then small organizations. And we could only have 128 large organizations. So, okay, that seems a little disappointing. I mean, there's a lot of companies out there that are huge multinational companies. There's way more than 128 of them. But the benefit for those people is that the host address is 24 bits long, meaning nearly 17 million addresses that each of those companies can have. Quick side message. If I have four 8-bit numbers, sometimes referred to as octets. I have 4 of them. 4 times 8 is 32. If 8 is assigned to the network, then 32 minus 8, that means 24 have to be assigned for hosts. All right, so I can only have 128 networks out there that are Class A's. Those Class A's have 16 million, almost 17 million usable addresses inside of that network. Great. Along with that, here's my range. Is 0000 through 127.0.0.0, and then it defines a default subnet mask of 255.0.0.0. This default subnet mask right here is essentially saying what the network address size is. Here I have 255, which is in binary, all ones. And my network address size is 8, which means the first 8 bits, or the first 8 ones here, are all network addresses instead of host addresses. That will make more sense as we move along and talk. Too much at this point, just know that essentially these two things right here are the same. Now, one thing to note about a Class A network is this one very special address, 127, or special network, actually. 127 is, in fact, referred to as a loopback. And a loopback is essentially a way of saying I'm talking to myself. Hey, it happens sometimes when I'm making a video and I forget to click the record button. I'm talking to myself. So the special network of 127, that could be 127.0.0.1, that could be 127, 255, 255, 255. That entire network range all refers to talking to myself. And there's a lot of special reasons why I may need that loopback capabilities. The reason why I bring it up here is because some people, when they refer to Class A networks, they don't refer to 0 through 127. They say 0 through 126. And 127 is something else. Both of these answers of 0 through 127 and 0 through 126 are both correct from your point of view. So if somebody says one, agree with them, especially if it's a job interview. If somebody says the other, agree with them as well. 127 is a special network, sometimes included, sometimes not included in the Class B range. I'm sorry, Class A range. The next network, Class B. And this time it's leading bits of 10. Remember when we're talking about the binary? So this is saying that if the very first 2 bits of a number is 10, so 10000000, which is 128, all the way up through 10111111, which is 191, is our range. Now, this time, instead of just having 8 bits to play with, we now have 16 bits to play with for our network address size. This is just simply the way that they defined it for a Class B network. If we start off with a 10, it's Class B, and therefore don't just look at the first 8 bits of the address, look at the first 16 bits of the address to figure out which organization for it should go to. 16 network address bits gives us 16,384 total networks. And then, because we have 32 bits total in an IPv4 address, if 16 is being used for the network, then 16 is used for host, which gives us 65,536 hosts per network. Now, if you're wondering why this is not equal to that, it's because Class A stole a whole bunch from the Class B network range. Yeah. So, range 128 through 191.255. Notice we're looking at 2 separate octets here, 2 blocks, 2 bytes of addressing, or 16 bits of addressing here. And then that same 16 bits is the 255.255.00 for the Class B. And then we have Class C networks. Again, leading bits 110. So if we look at 110, 0, 0000, which is 192, all the way through 110, 1111, which is 223. Then those are our ranges. Because it's a Class C, we're going to say the first 24 bits are the network range. So Class A is 8 bits, Class B is 16, Class C is 24. That gives us just over 2 million networks total. And then host size of 8 bits, or 256 hosts per network. Again, for the range, because we're dealing with 16 bits for the networks, we look at the first essentially 3 octets, or the first 3 bytes of our addresses. So 192.00 through 223.255.255 with a default subnet mask of 255.255.255. All right. Then we could talk about classes D and E. Well, class D, and E are unique cases. Class D and E are, class D is a multicast address. Multicast addressing is a way of saying I want to talk to more than one person at a time. So instead of having a one-on-one conversation, which would be referred to as a unicast, unicast, think unicycle. Instead of having a one-on-one unicast conversation, I can have a one-to-many multicast conversation. In this case, the leading bits are 1110, which gives me a range of 224 through 239. Additionally, along with that, we have an experimental range, which sounds really, really exciting until you realize, well, nobody's done anything with that experimental range. The experimental range was defined as just something we might want to use in the future, and currently nobody ever has, and therefore has a range of 240 through 255.255. One thing you'll notice about classes D and E, there is no subnet mask. There is no subnet mask. There is no networks per se, so there is no count of networks. There is no count of hosts. It is simply a range of networks or a range of addresses that can be used for multicast and a range that can be used for experimental. Now, why are these useful? Well, these are useful, again, for back in the day when the internet was not very smart. It was able to quickly and easily identify who is talking to who, or how you can talk to which person. Am I on the same network? Am I on a remote network? And then how do I get to that remote network if necessary? Additionally, some of these networks are used for just simply, these classful titles are used for simply organizing how we refer to these networks. For instance, in the tech world, you will oftentimes see people referring to creating of a Class C network. Why do they do that? Well, because of the size of the bits, because of how the subnet mask breaks off perfectly, and 256 hosts is oftentimes never too many hosts in a network and enough to be able to do everything you need. So we go through all this information so that we can then look at some of the configuration or some of the IP addresses and ask ourselves, what type of address is this? So if I see an address such as 12.17.42.65, I can then ask myself, which class is this? Well, if I paid attention to the notes or I looked over the Wikipedia page, actually, let me go over that really quick since I briefly covered it. The Classful Network Wikipedia article actually has all of that information broken down with even more right here. So if I look at that address of 12.17.42.65 and I look at that list of classful addresses, I can see this is in fact a Class A network. And then I can ask myself, what is the default subnet mask for this? Well, the default subnet mask is 255.0.0.0, and therefore I am in network 12. 12 is my network. If I have an address, let's see, 175.204.16.4. I can then ask myself, what class is this? Again, I look back at my nice little list here that's provided for me by Wikipedia. 175, and I look at, so I'm looking for 175. I can look right here at my start and end ranges. 175 is not yet Class C, so it's got to be right here in a Class B range. So then I know immediately this is a Class B network, and here's my subnet mask. So Class B, and my subnet mask is 255.255.0.0, which means right here is my break between my networks and my hosts. So this is my network address right there. And then lastly, if I see an address 202.217.192.4, I suck at making up IP addresses on a whim. And then I look again at my ranges, and I see 202 is what? Where does 202 fall into this? It's not quite a Class D. That's good. It's not a Class B, so it's got to be a Class C address. So a Class C address, and my subnet mask is 255.255.255.0. class B 255.255.255.0. And there you go. That is how IP addresses work. I would highly suggest for you guys to read over those articles, at least glance through them, and try to memorize this list right here as much as possible. Specifically, it kind of breaks into two different sections. We've got classes A, B, and C, which have a lot of unique information, specifically the ranges and the mask. And then we have classes D and E, which really is just the ranges to worry about.